Welcome to True Projects. In this video, we are going to explain about a project titled COVID-19 Future Forecasting using the Supervised Machine Learning Models. The project introduction emphasized the importance of machine learning in addressing the challenging real-world issues. It highlights how ML algorithms differ from traditional ones by relying on the trial and error rather than rigid decision statements. Forecasting is identified as a key application of ML with examples in weather, disease, and stock market prediction. The project is to showcase the ML model's ability to forecast the future number of COVID-19 cases given its significant impact and potential danger to humanity. The project's goal is to assess the effectiveness of the various machine learning models, including the linear regression, least absolute shrinkage and selection operator, support vector machine, and exponential smoothing in predicting the number of future COVID-19 patients. The objective is to showcase the model's ability to forecast the critical COVID-19 factors such as new infections, deaths, and recoveries over a 10-day period. The project evaluated the model's performance using the metrics like R-squared score, adjusted R-square, mean square error, and mean absolute error, and root mean square error. These are the basic requirements that are needed to build this project. Hardware requirements are operating system as Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirement: Python IDEL with version of 3.7. These are the modules that are developed to implement this project. The first module is upload COVID-19 dataset. Obtain the COVID-19 dataset and save it in the dataset folder and select that to upload the COVID-19 dataset. And it focuses mainly on total cases and date columns for the forecasting. And the second module is pre-process the dataset. In this dataset, we are handling the missing values, converting the date column format and splitting into the training and testing set. And the third module is run SPM algorithm. In this module, we are using the support vector machine algorithm to train a model on the training dataset and forecast the confirmed cases, deaths, and recoveries on the testing dataset, evaluating the model performance using the appropriate metrics. And the fourth module is run linear regression. Apply the linear regression to the pre-processed dataset, train the model, and forecast the COVID-19 variables. And the fifth module is run lasso algorithm. In this module, we are implementing the lasso algorithm and training a model, and using it, we forecast the number of cases, deaths, and recoveries. And the sixth module is run exponential smoothing. In this module, we are utilizing the exponential smoothing to train a model on the training dataset and forecast the COVID-19 variables on the dataset. And then seventh module is run LSTM algorithm. This module, we are implementing the long short-term memory using this deep learning library. Here, we are training the LSTM model on the dataset and forecasting the COVID-19 variables on the dataset. And the final module is all algorithms error rate graph. In this module, we are collecting the error rates obtained from each algorithm's forecasting results and creating a graph to compare the error rates of each algorithm and providing a visual representation of their performance. The execution of this project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files, and the dataset folder consisting of different files that are deaths confirmed, recovered, time series of the deaths confirmed, time series of the death recovered confirmed, and those on. And the temp folder consisting of confirmed death and recovered files. And the COVID forecast practice and the test of Python code files. And this is the run.bat file. Instead of executing the program in command line interface, we created the Windows bat file to execute the project. Now to run the project, double click on run.bat file. This is the graphical user interface. With this, we are interacting with the program. Now click on Upload COVID-19 Dataset button. By this button, we are going to import the dataset from this folder. Here I am selecting the dataset folder and click on select folder button. And here we can see that dataset is loaded. And also in this screen we can see that graph of death, confirmed death and recovered cases graph. In this, the x-axis represents the date and the y-axis represents the number of cases on the date. And this graph dataset size is huge, so the date values get collided from each as of like this. And close this graph and click on pre-process dataset button. It is used to read the dataset and extract the details from it. Here the screen we can see that the total dataset size is of 10009 and we used the datasets for training is of 9979 and use it for testing of 30. And now dataset is ready with the training and testing part, and now click on run SPM algorithm button to train the SPM and then forecasting and calculating the error rate. Here this is the COVID-19 SPM forecasting graph. In this screen we can see that error rate for each dataset. In the graph we can see actual forecast values too. In this graph, the red line represents the actual value and the green line represents the forecast value. And in this screen, we can see there is a huge difference between the actual forecast value and SPM is not performing well. To perform well, there should be close difference between the actual and forecast value. In this graph, x-axis represents the number of days and the y-axis represents the cases on that day. And close this graph. Here, the SPM gives and mean square error for the confirmed cases is of 0.08 and the SPM root mean square error for recovered case is of 0.09 and SPM root mean square error for death case is of 0.1. And then click on run linear regression button to generate the model. Here, it gives an COVID-19 linear regression forecasting graph. In this screen, we can see the root mean square error for the confirmed cases is of 0.04 and the recovered cases is of 0.02 and the death cases is of 0.03. And we can see in this graph that actual and forecast value difference is too much little. So linear regression is working well when compared to the top SPM model. And then close this graph and click on run lasso algorithm button. Here in this screen we can see that lasso error rate and the graph. We see that actual and forecast is having the narrow difference, so lasso is also working well as like of the linear regression. And then close this graph. Here, the lasso root mean square error for confirmed cases is of 0.05 and the root mean square error for recovered cases is of 0.03 and root mean square error for death cases is 0.04. And click on run exponential smoothing algorithm years button. Here, it gives an forecasting graph where the forecast value and the actual value as the close difference with it, and it is also working as well when compared to the top the LSTM and different other algorithms. And then close this graph. Here it gives an mean square error of 0.03 and the FS recovered cases is of 0.01 and the ES root mean square error for death cases is of 0.008. And then click on run extension LSTM algorithm button. We can see that LSTM generates an layers of total params of 101, trained params of 101, non-trainable params of 0. It gives the LSTM confirm the root mean square error of 0.001 and the mean square error for the death cases is 3.626 and the mean square error for the recovered cases is 0.009. And then click on all algorithms error rate graph. Here it gives an all algorithms error rate graph. In this graph, x-axis represents the algorithm name and the y-axis represents the error rate for each algorithm we used in it. And then close this graph. The project concludes that machine learning models, particularly the exponential smoothing, can be used to forecast the number of upcoming patients affected by COVID-19. The study demonstrates the capability of four standard forecasting models such as linear regression, least absolute shrinkage, and selection operator, support vector mission, and exponential smoothing and LSTM to forecast the threatening factors of COVID-19. The result of study proved that ES perform best in the current forecasting domain given the nature and size of the dataset. The project suggests that proposed ML-based prediction system can be used to predict the risk of COVID-19 outbreak globally, which can help in improving the decision making on the future course of actions. Thank you for watching.
For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.